Hey, welcome to Passages in Applied Mechanics by Dr. Lorenz Garcia. Today, statics. Bending of beams, bending stress. In this lecture, we are going to deal with the relation between the stresses induced in a beam by bending moments and certain geometrical properties of the cross-section of the beam. Firstly, we are going to discuss the geometrical property of centroids, a topic that might be familiar to you. Next, we will discuss the moment of inertia of a plane area and learn how to calculate it for a given cross-section of a beam. We will finish our lecture evaluating bending stresses in beams. Let's then start. Centroids of plane areas. In mathematics and physics, the centroid, also known as geometric center or center of figure, of a plane figure or solid figure is the arithmetic mean position of all the points in the surface of the figure. In geometry, one often assumes uniform mass density, in which case the barycenter or center of mass coincides with the centroid. Informally, it can be understood as the point at which a cutout of the shape, with uniformly distributed mass, could be perfectly balanced on the tip of a pin. The concept of centroid is often explained in terms of the center of gravity of a thin homogeneous plate of uniform thickness. See this figure when the centroid of a triangle is displayed. Centroids of areas are useful for a number of situations in applied mechanics, including the analysis of distributed forces, the analysis of bending in beams, the analysis of torsion in shafts, and as an intermediate step in determining moments of inertia. Moments of inertia of plane areas. The moment of inertia, normally referred by the letter I, of a plane area, more appropriately called the second moment of inertia, is the sum of all elementary products of area elements and the square of each respective distance from the centroidal axis. For our purposes, the moment of inertia of a cross-section of a beam, combined with another dimension of that cross-section, is a measure of the resistance offered by the cross-section to the bending moment and can be related to the bending stresses induced in the beam by bending. Moment of inertia. It is a mathematical concept which is best illustrated by examples. Moments of inertia of most common shapes have been calculated by means of integral calculus and can be found in tables and handbooks. Bending stress. Bending stress is a concept which deals with the relation between the bending moment in a beam, the stress produced in the material of the beam, and certain geometrical properties of the beam's cross-section. Let us consider a particular cross-section in a beam at which a bending moment, M, is applied. It can be shown that the magnitude of the bending stress, F, B, produced in the material of the beam at the cross-section is directly proportional to the bending moment. On the other hand, the size and shape of the cross-section of the beam give rise to a resistance which balances the applied bending moment. Bending stress is inversely proportional to the moment of inertia of the cross-section. One important difference between bending stress and some other types of stress considered previously is that, unlike direct tension or compression, bending stress is not distributed uniformly over the cross-sectional area of the beam. Every beam can be considered as being made up of a large number of horizontal layers or fibers held together by the internal adhesion between them. When a beam is subjected to bending, the fibers of the convex side are extended, while those on the concave side are compressed, as shown in the figure. Mathematically, the distribution of the stress in the cross-section of a beam can be summarized as the relation between the bending moment, M, at a given cross-section, the distance, y, from the neutral plane to a particular fiber, and I, as the moment of inertia of the cross-section. Let's apply these concepts to solve engineering problems. Dr. Lorenz Garcia here, thanks for watching. Ciao.